today's lesson in algebra we're going to do using SMART software. It's just a different method of delivery. So we're talking about systems of inequalities, which requires that we remember some facts about inequalities, which we learned fairly recently. Also, systems mean two variables, two equations. The first section that we want to talk about is section A. Be sure you're copying this down in your foldable. Part A is to identify are these solutions. Remember, all a solution means is an ordered pair that satisfies both inequalities or equations in a system, so both answers work. To figure that out, we're going to plug in to x and y, so that's how we're going to do that. Here's our first example. Our system is y is less than negative x plus 4, and y is less than or equal to x plus 1. Our solution is 2, 1, and we want to know, does that work? Now, it's important for you to remember when we're trying to figure out is something a solution, which one is x and which one is y. 2, of course, in this case is our x value. 1 is our y value. We know that because of ordered pairs. To figure out, is this a solution? We'll start with the first inequality. Y is less than negative x plus 4. We'll plug in the 2 and the 1. When we plug in the 2, it takes on that negative sign. So we've got negative 2 plus 4 on the right-hand side, 1 on the left-hand side. There's nothing to do on this side. On this other side, negative 2 plus 4 is 2. So finally, I have 1 is less than 2. That's true. 1 is less than 2. So I'm going to continue on. I'm going to check the second one. If I check the second inequality, I write it down. Y is less than or equal to x plus 1. I plug in my y value of 1, my x value of 2. There's nothing to do on the left side. On the right side, I have 2 plus 1, which is 3. And 1 is less than or equal to 3. So my answer here is yes. This is a solution to this system of inequalities. Let's try another example. The solution is 2, 0. The system is y is greater than or equal to 2x, and y is less than x plus 1. We'll start with the first one. Y is greater than or equal to 2x. And for x, I'm going to plug in this 2 right here. And for y, I'm going to plug in the 0. I'm going to perform my operations, so nothing to perform on the left. On the right, 2 times 2 is 4. And we know that 0 is not greater than or equal to 4. Since this is not true, the answer is no, this is not a solution, and there is no need to continue. If I was to get a yes answer, I would move on to the second inequality, and I would test it. If it was also a yes, the answer is yes. I have to have 2 yeses to get a yes answer. If it would have been a no, then the whole thing would be no. One no rules it out. It is not a solution. Okay, the next thing we want to talk about is B, graphing. That will mean that you need to recall some things that we talked about previously, that like the equation needs to be in slope-intercept form. Remember, that's y equals mx plus b. And then we'll need to remember some things about how to graph here in a second. So, on these equations, both are in slope-intercept form. The y is already by itself. Let's think about on the first one, is that one going to be dotted or solid? It will be dotted or dashed because there is no line underneath. And will it be shade above or shade below? It will be shade above because the greater symbol is near the y. So this one is dashed and above. On the second one, is it dashed or solid? Solid because it has the equal underneath. And is it shade above or below? Below because the smaller part of the inequality faces the y. Okay, now when we go to graph this, I've already got this graph. Let me help you see kind of what I did here. I brought in that dashed line and I shaded above. Now I'm going to move that one out of the way for just a second so that you can see I started with my y-intercept, which was 1. I crossed right here. Then I used that my slope was 1, and I went up 1 and over 1, up 1 over 1, up 1 over 1, and connected with a dashed line. Then that one was above, so I picked the side of the mountain I could walk on, and I bring this above. With my first color, I'm going to shade that in. We did that with some crayons in class today. For the second one, I don't have a y-intercept, or it doesn't look like I do, because the x is missing. When the x is missing, remember the y-intercept is just a number by itself, which is 2. So I'll start my graph at 2. And there is no slope. No slope means a slope of 0, so I'm going to go up 1 and over, up 0 and over 1, up 0 and over 1, which just gives me a horizontal line. And if I shade below, that would look like this. My answer then, let me kind of highlight that for you here. Grab a pen. That would be this section here. All of this cross section, or what we called in class the ugly color, this middle in between stuff would be my solution. Any answer I picked in this section would work for both of these. And that's how I graph systems of inequalities. Let's look at one more example. Okay, example number 4. Here are my two equations, my two inequalities, y is greater than x minus 7 and 3x plus 6y is less than or equal to 12. The first one is solved for y. I know my y-intercept is negative 7 and my slope is 1. Because there is no line underneath, I know that this is going to be a dashed line, and the larger part is facing the y, so it will also be shade above. Let me move that out of the way. On the second one, the problem is my y is not solved for. So I need to do that first and foremost. So I'm going to take my pen. Let's work that out together. Okay, to get y by itself, it's being multiplied by 6 and added by 3x. So I'm going to subtract 3x from both sides. These will cancel, and I've got 6y is less than or equal to negative 3x plus 12. To get the y by itself, I'm going to divide every single thing by 6. Remember to watch out for multiplying or dividing by negatives. If you do that, you've got to flip this sign. We didn't. I just want to bring that to your attention in case you forget. And then I've got y is less than or equal to. I can reduce my fractions. Negative 3 over 6 reduces to negative 1/2 x. And plus 12 divided by 6, of course, is 2. And that's my new equation. My line is a less than or equal to, so it is shaded below. It is also a solid line. So I can kind of clear those things. Let's go ahead and work our lines in here. So our first line is going to start at negative 7. That would be this line right here. See how it's going through the point negative 7. Let me grab my pen right here. And then my slope was 1. So I went up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, and did a dashed line. That's what you should be working on right now. And then it's shade above. So I'm just going to pick a color here. If it will let me. And I'll pick this kind of blue shade. And we're shading above, so, oh, it didn't take. Okay, well, I'm going to shade with my red then. And I'm going to shade this area in. You should be doing that with your crayon. My second line starts at 2, and that was this one right here. And my slope is negative 1/2, so I'm going to go down 1 and over 2. Down 1 and over 2. And continue on that pattern. Draw a solid line. And then, hopefully, maybe now I can get... Maybe if I hit save. Okay, and I want to shade below that line. So I'm going to shade here, everything below that solid line. And then my cross section, guys, I'm going to shade that in this green color just so that you can see that my cross section, yours should make I called it the ugly color. It might have made a pretty color on yours. This should be this in between. This would be your solution right here. Meaning any point within that region, any point in this section right here, is going to work in both of these inequalities. Your assignment for this topic is A8. It's page 424, 2 to 4, and 9 to 14. Good luck, and let me know if you have any questions.